Okay. Hello and welcome to the Digital Twins session. My name is Will Hastings. I'm an analyst at ARC Advisory Group. I cover PLM, additive manufacturing, and more recently, digital twins. So this session is going to be a little bit different. We don't have end user speakers, but we do have a six-person panelist representing some of the major software suppliers that are facilitating the concept of digital twin. And so I'll be giving a short presentation that covers digital twin from ARC's perspective, kind of outlining how we think about it, and as kind of an architecture for how to discuss it at ARC. And then we'll be moving into a Q&A panel discussion. So I started researching digital twin about 6 months ago, and one of the first things I realized is there's no real true definition for digital twin. It really depends on what website you're on, or what industry you're in, or what applications you're trying to use it for. And so I selected kind of a cross-section of these definitions, and they're all kind of right, but they really don't facilitate a broader discussion of digital twins. So I made it my job at ARC to kind of look at digital twins from a broad perspective and then break them down so that the individual analysts at ARC could have a talk about digital twins regardless of whether they were focused on process industries or maybe simulation or maybe computer-aided design or perhaps IoT. And so the general structure that we talk about digital twins, first, of course, you have a physical asset or process that is replicated with the digital model, which provides context or characteristic data. And then you have real-time data that is fed to your digital twin from that operation or product. This provides the operational states or behavior to your digital twin. And then lastly, but somewhat less clearly, is this idea of an information model, and that's what integrates your contextual data with your real-time data coming from your process or your product. And then, of course, you can add analytics on top of that or embed analytics within it. So diving down a little bit deeper into each one of these, the digital model is a model that needs to be sufficiently complete to predict the behavior and the performance of the underlying asset or process. And so there are really two parts of this. There's your context, which comes from 3D models, bills of materials, maintenance procedures, product or process specifications, process diagrams, even things like your process specifications or specifications coming from a client. These all kind of inform the identity of the product or the process and act kind of as the DNA of the digital twin. And then you have the prediction side of things. So these are your simulations, whether they're physics simulations or machine learning simulations, control models, et cetera. So some kind of things to think about when you're talking about this element of the digital twin are things like the prediction complexity. So how hard or difficult is it to actually run these simulations and get a prediction that makes sense to your application? What are the accuracy of these predictions? And then what is the value of that prediction compared to the investment in your digital twin? So a lot of this really comes from the engineering technology side of the fence. So the next is the real-time data, and this provides relevant operating data, and it needs to be collected with adequate fidelity to compare the model predictions with your operational performance. And so this is what really tethers the digital twin to the actual underlying asset or process. So one way to think about this is all the different data types that can be drawn here. So this is things like process data, machine health, maintenance data, quality control, and so forth. Even things like schedules. Some key points to think about when you're talking about real-time data. What is real-time? So depending on what your application for digital twin is, this might vary wildly. So an example would be a digital twin of the construction of a plant. And so real-time might be every 2 days you get a drone to do a 3D scan of that facility and update your models. So it's all about what's necessary to facilitate the application that the digital twin is used for. Some other concepts or key points are implementation of data collection. So how are you actually collecting that data? Determining the volume and fidelity of that data that's necessary for your application. And then also, of course, ensuring the quality of that data throughout the life cycle of the plant or process or product. So a lot of this is mainly focused on operational technology. And the last, more, I would say, obscure aspect of the digital twin is the information or the data model. And so this really formalizes the relationship between the models and the data, and it acts as your source of truth for anyone who's trying to extract value from the digital twin. And so this provides integration and identification, the properties and relationships between the data. And then a key point here, which is something that was a point of a lot of discussion, is the idea of synchronization and reconciliation. And so this is, how do you make sure that the models of your digital twin are always up to date and reflect the underlying asset or process? And so the information model can be utilized to help facilitate that using the data that's coming in to augment the model that you have. So some key points here are the various data structures that you need to combine in order to make this work. The governance, so how do you federate the data of your digital twin internal to your company, but also external, for example, for services. And then tuning the digital twin to make sure that the models that you have reflect the actual underlying asset. So this is kind of the information technology. So I really think of the digital twin as really like a culmination of the IT-OT convergence that we've talked about here for years at this point. So there are really two types of digital twins when you get down to it. At least this is how ARC sees it. So there are challenges specific to industry and application, but there are also very specific challenges depending on the type of digital twin. So we look at this from the perspective of project digital twin and performance digital twin. And so the cycle here, there's kind of merged cycle, and in a lot of cases, a project digital twin provides a lot of the digital assets that you'll then use for your performance digital twin. And so the project is really the outside of that cycle. So it's the building and modeling, the connecting and collecting, analyzing, executing, and optimizing, and then innovating to allow a better project next time. And so this is really the idea of closing that loop from engineering to production and then back to new product development. It's often used to accelerate program timing, increase product fitness, reduce costs, and so forth. And then within that loop, you have the performance digital twin. So this is where you analyze the data, execute and optimize, then continue to collect that information, continue to analyze, and you go through this cycle for as long as your plant or process or asset is in the field. And this is essentially the digital twin associated with optimizing a process. So there are a lot of technologies that are driving digital twins. The companies that are represented here provide a lot of them. So I'm not going to get too deep into them, but things like building information modeling, obviously cloud computing, 5G communication to facilitate collection of data, simulation technology across the board, and so forth. So these are just some ideas to think about and maybe draw on for some of your questions.